So when we're factoring polynomials that aren't quadratic, and we have trinomials where our powers are all even, so instead of having x squared minus 3x minus 4, we can use the same idea to factor this when it's even powers. So when I have the fourth and then the second, or I could have like the eighth and then the fourth. So the idea is that this power is double that power, the same way that it is in a quadratic trinomial. And so I still start the same way, where I want to identify A, B, and C in the problem and find the product sum using those values. So for this expression for A, x to the fourth has a coefficient of 1. Negative 3x squared has a coefficient of negative 3. And then the constant C is negative 4. And so to do the product sum table, remember that we're multiplying A times C to find the product. And so 1 times negative 4 gives us negative 4. And then the sum is just the value for B. So in this case, it's negative 3. Okay. So we're looking for two numbers that multiply to negative 4 and add to 3. And so in this process, what we want to think about is each of the factors of 4. Since there's only two pairs, I'm just going to list both of them. So force factors are 1 and 4, and then 2 and 2. And so because this needs to multiply to a negative and add to a negative, I know the larger of the two numbers needs to be negative. And so since 2's are the same, it doesn't really matter which one we use, because notice that when I add those together, I get 0. And then when I add those together, I get negative 3. So that means that our pair of numbers is 1 and negative 4. Remember that when A is 1, we don't necessarily need to do grouping. So whatever this middle term is, in this case, x squared, that means that we automatically know the two binomial factors are going to be x squared with the two numbers from our product sum chart. So that means we're going to have x squared plus 1 and x squared minus 4. And so what changes when we have this power of 4 is that our results are quadratic now. And so that means that we have to identify if these are factorable too. And so we have to find the product sum for each of these. So if I start with the x squared plus 1, I'm looking for two numbers that multiply to, A is still 1. There is no x term, so remember that means that B is 0. And then C is the constant 1. So I need two numbers that multiply to 1 times 1, which is 1. And so I know those two numbers are 1 and 1. Because the sum is 0, I know that they need to be opposites in order to add to 0. However, this tells me that the two numbers are the same sign. So it would have to be 1 plus 1, which would give us 2. Or it would have to be negative 1 plus negative 1, which would give us negative 2. And so what that tells us is that x squared plus 1 is actually prime. So we cannot factor x squared plus 1. And so we know that in our answer, we're just going to have an x squared plus 1. However, the second factor is factorable. So if we're looking at x squared minus 4, for this one, the value for A is also 1. And the value for B is also 0. So notice that we have no x term again. And why this one works is because our value for C is negative. So C is negative 4. So when I multiply 1 times negative 4, I get negative 4. And I want it to add to 0. And so when we had 4 in the first set of values, when we were factoring the original problem, we were looking for it adding to negative 3. Now we're looking for it to add to 0. So notice that it's the same as in this table, right? We have that 2 plus negative 2 that we already saw equals 0. So that means that x squared minus 4 is factorable. And since it's x squared, we know that it's going to be x's. So we're going to have x plus 2 and then x minus 2. Okay, so the big idea with this these problems when we have a power a higher degree is that we keep factoring to get x squared. We might not but we want to get x plus or minus numbers if we can. Okay, so this is an if possible. I should have written this below, sorry. So if it's possible, we want to keep factoring to get these linear binomials because some of the quadratic binomials are factorable. Specifically, if we remember what this is called, it's a difference of two squares. So that's when we will be able to factor difference of two squares. So those are the cases where we'll be able to factor our result. So in part A, we had an A value of 1, and so we didn't have to use grouping. We knew that it's just going to be 1 times x squared as our first term. For a problem like B, where we have 7, we know that one binomial is going to be one factor of 7, and the other binomial has to be the other factor of 7. So if we look at this expression, 7x to the 4th, our A is 7, our B is negative 15, and our C is 8. Sorry for the tapping, I need to slow down. So then A times C, 7 times 8 is going to give us 56. So we're looking for a product of 56 that adds to B, which is negative 15. Okay, so we would be factoring 56 until we see two numbers that add to negative 15. I would always check the numbers you use to find 56 first and see if those work when you have a bigger number like 56, because 56 does have a lot of factors. And so notice that if 7 and 8 are both negative, that does equal negative 15. So that means that what we can rewrite this as is we have 7x to the 4th still, but instead of writing the negative 15x, we're going to use these coefficients to split. So minus 7x squared and then minus 8x squared. Remember, it doesn't matter which order I use these terms in. It would just kind of switch the way that my factoring works. And then our constant was 8, so plus 8. Okay, so we took our original 7x to the 4th minus 15x squared plus 8, and we rewrote that negative 15x squared as minus 7x squared minus 8x squared. And so when we have an A value that is not 1, that's when we have to do this and use grouping. So we're splitting our 4 terms in half, and we're going to factor out the common factor of each pair of numbers. And so our first two terms are 7x to the 4th minus 7x squared. So this expression, I can factor out the coefficient because they have the same coefficient, 7. And I can also factor out an x squared. So whatever the lowest power is on x, I can factor that out. And so if I divide both of these terms by 7x squared, I'm going to end up with x squared minus 1. I want to do the exact same thing with the second pair of terms. So I've got negative 8x squared plus 8. Whatever this sign is in front is automatically going to be carried down. So I'm either putting plus something or minus something, depending on what that is. And then I want to look at my factors. So I can factor out an 8 because both terms have an 8. The last term doesn't have a variable, so I can only factor the 8. And so remember that that means that we're dividing both of these terms by negative 8. So that's giving me a positive x squared. And then positive 8 divided by negative 8 is giving me a negative 1. And so remember that the whole idea with grouping is that these two factors are the same. And so they have this common factor of x squared minus 1 now. And then when I divide this by x squared minus 1, it's going to cancel out, and I'm left with the 7x squared. And when I divide the negative 8 times x squared minus 1 by my common factor, oops, I'm left with plus 8, sorry, minus 8. And so my two factors so far are x squared minus 1 and then 7x squared minus 8. And so remember that when we're doing this last step and we're checking to see if these factor, we're looking for a difference of two squares. And so notice that this term here is, or this factor here is the difference of two squares. And so I know that the same way that when we had x squared minus 4, it turned into x plus 2 times x minus 2 because the square root of 4 is 2. And so notice that x squared plus 1 didn't work because we had to have the same sign on the ones. And so this one will because I can use x plus 1 times x minus 1 because x squared minus 1 is a difference of two squares. 7 is not a perfect square, nor is 8. And so that means that this factor is just part of our answer, 7x squared minus 8. So the big idea with these quartic polynomials that are trinomials, we can factor the same way that we would factor a quadratic trinomial. But then because we have a quadratic binomials as our result, we have to look for really just difference of two squares. And anytime we have one of those, we can factor that down to be linear. And so that's factoring with higher degree polynomials, specifically quartic trinomials.